So about the project, BIM4EEB in a nutshell. So we are creating this toolkit, which is BIM based and aims to efficient renovation. And we have been doing the project since beginning of 2019, and it will end next June. So this is the final workshop for this Finnish part. And the whole idea of the project is digitalization of renovation. So as said, BIM-based toolkit, and tools will allow these 3D digital models of existing buildings and utilizing that one. And there is the common data environment, the BIMS, in the background connecting those other tools. So in the first phase of the project, so that is the toolkit. We don't have used all of these in the Finnish pilot, so today we are talking only about the BIM system and BIMPlanner, BIMeaser, and fast mapping toolkit. So in the first phase of the project, we defined requirements from the user's perspective, so different companies, and we also defined this linked data and ontology approach that have been used in the tools. Then in the second phase, we developed those tools, and the third phase was testing them in the pilot sites, and one of those is the Finnish pilot, which we are talking about today. And that would be my short introduction to the project. So then I would give the floor to Olli, who would tell us something about the Finnish pilot.
Hello, I'm Olli Nummerin from Caverion, and I hope you can see my screen now. Sorry for hassling a little bit my buttons. I will tell a few words about the Finnish pilot site. No. Okay. The Finnish pilot site is a residential building located in Espoo in Finland. Originally, we had another residential building, and this is quite similar compared with the original one. And that building is owned by Keva, that is an insurance company, quite a big company. The building itself, it has been constructed in 1992, and it's quite typical building built at that time. It's made from precast concrete elements, and all structures are typical, so there are dozens of that kind of buildings in Finland. The building is connected with district heating network, like most of the buildings are in Finland today. And energy rating class is D according to the national rating, so that's also typical for that time. And here you can see some key figures. It's about 14,000 cubic meters, and there are 43 apartments, 5 floors, and 3 staircases, and one photo about the building over there. So the pilot itself, our objective there was to reduce primary energy consumption about 50%, and do that with the minimum action, so with the minimum cost and only the necessary things that are needed for that. And in practice, we decided to install an exhaust air heat pump. So that's the system that in this kind of buildings, we have an exhaust air collected at the roof of the building, and the new system is recovering energy from that air, and that air is constantly about plus 22 degrees all year around. So in Finland, that's a big advantage compared to the traditional heat pump, because during winter time we can recover heat from indoor air, but not from outside. And that system runs in parallel with district heating, so we can use district heating still during the peak demand and for domestic hot water, but for the heating we are using mainly the heat pump. The economy of the renovation, the total budget is about 150,000 euros for the renovation work. And that case is based on the long-term collaboration with the client. And we have a collaboration agreement with them that we try to reduce 7% of energy consumption and 10% of water consumption in their residential building during a couple of years. Totally, during the first year, we have already reduced 6.5 gigawatt hours of energy consumption. So this means that in practice, we can replicate this kind of process, and actually there's a next one already going on with that client. And we follow the objectives on the client level. So we follow if we can reduce energy consumption in their whole building stock, not only in one building, but in all of those buildings. And the source data, we started to find documents for the building, and typically there's drawings, original drawings. It's a pile of paper, and that was the case in this building as well. And we created an IFC model based on the original drawings and modifications that we provide for this building. And this this IFC model is used for the toolkit in this project, but we use that information for visualization and for energy analysis as well. So it's not only for the project, but for some benefits for traditional work as well. The data that we are getting there, we know the energy consumption. We have been tracking that for a long time, so we can compare what happens after a renovation. There are building automation system from Oman installed in that building a couple of years ago. So during this process, we have some extensions, including the heat pump there, as well as some other features and feedback. And there is some sensoring from different data points. And we have found already that there are some challenges with the indoor conditions in some specific spaces. And the schedule of the renovation, we started the renovation last year during June, and it was completed mostly during the December last year, but there are some final actions to be covered during the couple of next days, and everything will be completed and adjusted at the end of this month. So that's the pilot building, and I'm happy to answer questions if there is any. Thank you.
Perfect. We start with the BIM management system. The BIM management system is the core of the BIM4EEB project in terms of that manage the data that is inside the project and integrate the tools that after my presentation will be presented. The main goal is that, as we know, the optimal information management is one of the best challenge, the current challenge in the construction industry. And we also know that the amount of data generated by a building asset during the entire life cycle is massive. And this could be an issue and could hinder strategic decision. With this goal in mind, a common data environment, as we know, is a CDE, work as an agreed source of information. And this can help to collect, manage, and dissemination all the information through a managed process for the entire building. And what we have to do in the project about the BIM management system is to create this common data environment. This is the first page of the BIM management system when the user entering in the project, and the basic functionalities are to support all the construction stakeholders for the whole process, for the whole life cycle of the building. Obviously, save models and all the documentation about the design, construction, but also the management of the building during the operation side. And also store all the live data on site, basically bringing from IoT devices like sensors and so on. And finally collect also feedback from inhabitants and all the stakeholders. is available on the internet for registered users. In this moment is just for the participant in the project. And as we said before, basically we store all the data, and the data is in terms of a common data environment, and these are a pair of screens of how this data can be viewed. For example, you can store models, documents, images, videos, any kind of data format that is most common used by professionals and users, inhabitants, for example, on owners, can be stored here. And we have a lot of functionalities that permit to and allow to share the data with other users, and take track of changes with the revisions, take changes of status, the document status, and be also aware about the models. As you know, the BIM processes are most important, and the BIM management system supports the BIM, also giving a BIM viewer that allow the users to see the building and to navigate through the hierarchy of the objects, the elements, see the properties, and see all the data that could be attached to these items. Another important feature is to see where is the building is located, but also all the resources of the building where are located. And these are a component of the GIS technology that we can see that where there is the data in terms of geographically location, and also see, as we see in the next slides, how this data could be connected to other data. IoT information, for example, we see the temperature inside apartments, could be seen there. Obviously, there is a private system that not all users can see the data coming from the apartments, but just the users that have the permission to it. And this data could be seen as a tabular data, but also in terms of more easy, in terms that you can select the apartment and see, for example, which are all the components of the sensory measurements in a precise time. Another important thing is that yes, the user can navigate through the model and see all the information that needed. This is right for the design phases, but also for the operational phases. If you are, for example, a real estate manager, you can check how is the building, how is going in the building. We have a classification system that help to find the resources. We have some functionalities linked to the linked data resources. There's a special feature that report in-house the linked data functionalities, and some things that could be related to the data associated to the documentation, to any kind of document that could be stored inside the system. And obviously there is a connection between some most used applications in professional users. Another important thing is that as we see that the information is most important, it's important to take track of changes, take track, for example, of the approvals in one document, to see which is the step-by-step evolution of the documentation, and collect the feedback, collect, for example, the approvals, if a documentation can be ready to be shared with any other. Another important thing is about the building logbook. This is important, especially for managing an operational phase, when you have to check all the data of your building in time, historically registered or recorded in the database, when you see where are the changes. For example, when you change the last heating equipment, and this data could be stored entirely in the BIM management system and can be shared with the people that are interested. All the data could be searched in the special case using linked data features, and especially a SparkWell endpoint that is a very powerful system to check the data about the linked data. And one of the most used and precious feature of these functionalities is that all the data that you can store in the system can be connected and linked with external resources. For example, for the city of Espoo or Tampere or any location that are present in the BIM management system, you can search for any other information that could be useful for the building. For example, you can see which are the buildings near your building and see if there are some information available to recognize something interesting for your building. This could be unhelpful for designers, but also for any technical leader that are working your building. This a practical example about this functionality is located in this case not as a video that for Italian demo site, but could be applicable for any location stored in BIM management system, where you can see that your building could be in Milan, for example, but you can see that what is other buildings, other information available near our building in a circular kilometers from our building, and this information could be reached from other resources, and it could be something that we can call augmented information for the system. Just last thing to not go hangover so much in this presentation, we have some functionalities that this data is stored in the BIM management system, but it is available for example, for any other tool. We have an API that could extend and integrate other tools inside the building management system, and this can allow to data exchange between tools in a way that is more fast than before. A bottleneck process is so much in upload and download features, documents, and so on, that could be waste some time for designers, for every professional that works in documentation of the building, and we create a system that you cannot have to exchange every time the same file, but you can just upload the first time your resources and just integrate only the data. For example, if you have a building model in IFC, you have just to upload first time your BIM model, and then if you have to change something in the data inside the BIM model, you have just to use the API to update the system. And this could be a very powerful system that can reduce about 17% the time operating in your model. And then I don't know, Teemu, if I have some more minutes to spend on that. The other slides are about this kind of process that can allowed by BIM management system to exchange data between tools. The next tools that you see in the presentation is about that, working with the API of the BIM management system, and can exchange data with that. Is an integration with the most common tools used by professionals. And yes, this is my last slide. I hope I give a good environment, a good presentation of the BIM management system. I leave to you the stage.
I will. Can you just. Yes, I can see it. There I am. I'm from Sweden, working at the Research Institute of Sweden, and I will present today the part in this BIM tools which is called fast mapping tool. And
the object and the goal with this tool is to easier obtain the documentation of the construction of the existing building, and also get more information than you normally have when you create your 3D model and you have the geometry, some construction parts and so on. And when you have this 3D model with the more information, it's easier to understand the construction when you see it in the 3D model. Okay, so how does this work and what is it? The first step is that you scan the department or the room with an ordinary laser scan. You see it on the first picture here. This laser scan creates a point cloud. You see it on the lower picture. This point cloud is, because it's dead information. It's just points. The computer doesn't know if it's a window or if it's a wall or a floor or what it is. And there the toolkit comes in. Because when you have this scan and you have the point cloud, then you can put on an AR glasses, augmented reality glasses, and upload the point cloud in the glasses. So when you put on the glasses, the glasses is transparent, so you can see the room, the apartment, and then you upload the point cloud, and that's what you see in the lower picture here. You can see this is a wall with a channel of cables. To the right in the picture, you see just the wall. To the left, you can see it's a point cloud together with the real wall. When you have this point cloud in the glasses, then you can very easy add with your finger and define what is what. So you can point on the wall and say that this is a wall, and you can point on the corner in the floor and say that this will be a floor, so that the computer knows what it is. And then you have another thing, which is the one I like most, I think. It's when you have this, then you can connect what we call a sensor stick. And this is developed in the project. So this is nothing who exists on the market at the moment. This sensor stick is like a normal sensor for measure moist. You know, when you will inject the studs and moist in the wall, it measures capacitance, inductance, electricity, and temperature a few centimeters in the wall. The good thing with this is when you sweep this sensor stick over the wall and have the glasses on you, you can see this little screen or layout in the glasses. So you can see what the sensor stick detects. So you can see if it's measure high capacitance and if it's measure inductance or electricity and temperature. What it measure, you can detect it as a color. So what you see to the right here, you see different colors. It's colors who is added to the point cloud or to the wall. It's one color for each measurement. So when you have the glasses on and you see the different colors, you can say that probably you have a cable here and you have a stud here, or you can have maybe you have some moisture problem or some area which is air gap behind or something. And then you can easily point with your fingers and say that here it is and here it is and here it is. And this is what I have done here. I have just indicate where stud could be. I can say it isn't really that easy as I say it is now, because when you detect it, you have to be careful and see that it's in line with the point cloud. You see the first picture here, it's the beams are tilted a little, so you have to adjust them so it becomes correct. And once you are satisfied, it's possible to create an IFC file that could be stored in the BIMS model that you saw previously. This is new things. What is existing today? The laser scanning exists today, and also the AR glasses. That's possible to buy on the market and use. And what's new in this project, what we had developed, is the sensor stick and also the software. So this is a tool which is demonstrated in this project, and it will need some more development before it will be a good tool on the market. Next week, this will be demonstrated at your demo site in Finland on Tuesday. We have booked, and then we will do a laser scanning of one room or maybe 2 rooms if we have time, and it will be a point cloud, and we will also do mapping with the sensor stick to see what we have behind the walls. Okay, I think we have time for question if you have. Okay, if there is no question, then I give the word back to you.
Okay, I hope you can see the presentation, which is about the decision support tool, BIMeaser. And my colleague, Jari Semeikka, has been a key person in this development work. I have also worked with this, but not that much. But unfortunately, Jari was not able to join today. So he prepared most of the slides, but I will show them today to you. So BIMeaser is the early stage energy scenario tool, and the idea is to create the decision support tool for early design phases. And the main functionalities of the tool are to model the so-called as-is energy and indoor climate model of the building to represent the baseline energy consumption before those renovations. And that is based on the data that we get from BIM management system. Then the second functionality is to model the renovation scenarios, and they also get data from BIM management system, but also supporting national databases that have the actual cost for those renovations. And then finally, the tool calculates the impact of each of those renovation measures, and that's how the decision can then be made, which is the best option. So if you look at the design or the renovation process chart, there is of course increasing amount of information in the process, and in the end it is common to use those sophisticated energy simulation tools. But in the early phases there is a gap in the information that is needed for those tools and what is available, and that's the scope of our tool to improve. The basic workflow is that there is a design team and a specific user, energy expert in that team, and he will be the one using the tool. The content for the as-is model comes from BIM management system, and building energy simulation model is created with that. And then there is this BIMeaser tool that also gets the data from national databases, and then those scenarios are created and sent to Energy Simulator, which is a commercial software. So we didn't reinvent the wheel for that, but used the existing IDA-ICE simulation tool. And as a result, the BIMeaser will provide these owner's project requirements. Benefits of our approach is that it allows high resolution baseline energy models because it gets better data. It comes automatically, and it allows application and testing of various scenarios in those early phases, and it also enhances collaborative work inside the design team as those scenarios can be evaluated quickly in the work. These are the actual OPRs, so owner's project requirements that we are calculating. So energy savings, comfort, and cost. And that is how the tool looks. So it is used in a browser window. There are external connections and then those renovation measures and the scenarios defined. And then finally it will provide this table of OPRs. That is how the national database looks like in the browser window also. So the data is collected there as like this. Our case study here was the older Finnish pilot. So as Olli mentioned in the first presentation, the Finnish pilot was changed during the project, and as we were working in the early phases, so we already tested our tool before the pilot was changed, and this was the previous site, pretty much similar as the one that was actually implemented, but this was also about the installation of a heat pump. So energy saving measure there was this exhaust air heat pump, and we estimated the price for that. And that is how it all looks when it is simulating in the IDA-ICE tool. And here are the cost, energy, and comfort indicators that were calculated in the evaluation. So the final result of this tool, it was clear that it will reduce a lot the modeling time versus manual modeling. So we actually clocked that with having one expert trying to do the modeling work as it is normally done. So collecting the information manually and putting it into the simulation tool, and then we did that another time with another expert who used the system developed in the project, so the BIM management system and BIMeaser to create the model, and we were able to get this 80% reduction in this pilot, and I think it was 75% reduction in the other pilot. and especially it is this build of the as-is model, so the first model for baseline simulations that went much faster with these tools. So as a summary, the tool worked nicely, and the demonstration was successful with this decrease in the modeling time. And in our opinion, it clearly adds value to the work of design team in those early phases. Maybe some development ideas that we got in the previous workshops was that, of course, the simulation could be faster. So it could be a cloud service with a lot of cores to do the simulation. That maybe would help it go through faster. And then when we are doing the baseline model and it needs to be calibrated to match the actual measured consumptions, then maybe there could be some artificial intelligence-based calibration algorithms to automatize also that part. But maybe some other project will work with those then. That's what I would like to say about BIMeaser. And maybe again we have time for short question if needed, or you can put those into the chat.
Mika here. From EQVA, I just want to give a comment for these further development ideas. EQVA is working with the cloud service already. Unfortunately, it wasn't available at that time when Teemu and Boris started this demo. And this idea of this artificial intelligence to calibrate the model it's a very good one, because then the end result from the NSE project they are as reliable as the basic model is, the baseline model is. So it's a very good idea to tune it with at least by hand, and more preferable with the artificial intelligence. So I do like these ideas, Teemu. And no questions so far. Thanks.
So this, what we call BIMPlanner, is one of the tools developed in this BIM4EEB project. And as briefly described, it is a cloud-based scheduling software for detailed planning and tracking activities, especially at the renovation site. And we think that it is based on this so-called location-based construction management method, where all the activities are scheduled to certain location, work location at site. And we think that in renovation project, where there might be the occupants at the site environment, it would provide some safety information, but also possibilities to indicate of coming, let's say, disturbance from the construction work. That was our initial idea for this tool development. The other development domain here is that we are using this linked data approach. We store all the data as a so-called triplets in a graph database, which is not a new domain, but application in construction management is quite new. And I will later explain why we have tried this kind of approach. And of course, this tool is based and linked with this for example, to share this BIMPlanner data with other BIM4EEB tools. On the other hand, in this specific demonstration project in Finland, we do not have such information exchange with other tools, but in this Italian demonstration, there is some data. As I said, that the tool is based on this location-based construction management, where the idea is that the activities are, let's say, flowing through the different work locations, and we could define the timing for each work location. So it will conclude in more detailed planning, but also possibility to track is the the activity in certain location, is it finished or not? And with this approach, we link those work locations with BIM model. Then we do know where actually the work is going on in a, let's say, geometric sense in the site coordinate system. And this Finnish demonstration project, as Olli earlier described, it is exhaust air heat pump system installation. But in this case, it is not very large an activity. It has two or three major locations where the work is done. The most crucial is this technical room, where are all those equipments installed indoor. Then we do have need to work on roof. There are 3 heat recovery units on roof, and also this needed piping to transfer the collected heat from the roof to the technical room for the heat pump. So in this sense, this location-based management may not be the best demonstration environment, but I show what we have done and reached. As I said, that we do have in this BIMPlanner a user interface for defining those work locations. And as I said, there is just few locations in this case. We have this technical room. We have in the facade some area for where the piping is going on, and also we have some locations where the heat recovery units are installed on the roof. But even though here is 3 different locations where these recovery units were installed, we made the planning just this roof as a one work location. We did not divide it in those 3 locations, because there are some activities that during same day the worker could make some installation for each of those units. We had a master schedule that was agreed by the client and Caverion, and also the subcontractor who implement the activities at site. I'm not sure how clearly you can see the fonts here. Those might be quite small, but briefly, if I go through those, there are some deliveries of the equipment to the site. There are some construction work. There are these heat recovery installations, piping, unit installation and connections. There is MEP installations, mostly the heat pump, and related electrical installation and building automation and control system installation. And the total planned duration for these operations were at site were those 13 weeks. And there were some, let's say, reservation buffers in the schedule. There was in the start and end about 2 weeks for manage if something goes wrong. And if we check the implementation, here was the construction work, which actually was an installation of suspended ceiling in this technical room, because there were expectations that some improved sound insulation shall be applied, and it was firstly installed in the technical room. Before that, there were need to make some removal for the electrical installations in order to be able to make this suspended ceiling. And it was planned and actually implemented in time. Then at the roof, these heat recovery installations, they were probably the most biggest problems in the work. Most crucial work has been this piping installations on the roof and also in the facade. It was taken about 2.5 weeks time. It was finished in a latest plan, but there were some problems to reach to apply some components in the facade, and it was in that sense late compared to the initial plan for these installations. There were some other related installations, and probably the most biggest delay was in this connecting those units and piping system on the roof. But this was actually, there was let's say the work was delayed due to some sick. The worker were sick, and there was problems to implement it, but there were no problem in a total schedule. The works in the technical room, the heat pump installation, the related electrical installations, and building automation and control system installations were implemented in time. And if we check the total schedule, this might be too small font to see, but we can recognize these, let's say, light blue or gray areas here in the start, middle, and the end of the project. They are some, let's say, lead time that could be left out if there is a need to reduce the total duration of the project. We can see here with the green color some activities which were implemented in a shorter period than planned, and there are some delays on these works. But this was something that we really done on cooperation with Caverion and subcontractor Tom Allen Senera named company. As I said, that this has been for us also let's say computer science, not research project, but development project. We do have invested in developing this system where the data is stored as linked data and also communicating with the BIM management system. And just to motivating that, our idea is that in one day we could make all construction project data available to create a common understanding where the all work are going on. And in this BIMPlanner implementation, we applied some area where we could provide this information in I would not say standardized, but in a systematic way, following these BIM4EEB developed Deacon ontologies in order to create some other added value on the data that is produced on BIMPlanner. And of course, we had some let's say defects and findings and surprises during those discussions, we have found how we need to improve BIMPlanner. We have some thoughts how this kind of a project may be managed, because it seems that this is not a typical renovation project. It is too small to short duration project, but on the other hand, it is not related on maintenance and typical repair work that Caverion is also providing to these clients. So there is need some let's say streamlined process for such projects, because it is quite obvious that such system installations, there is a rising demand in the future in order to improve the energy efficiency. Thank you for my side.
Okay, so that's our schedule. Next we will start the interactive part of this workshop to really work on something together. So I will introduce the tool very quickly first, then we will have a 5-minute break, and then continue with discussion and feedback on this tool. So we will be using this Miro tool for this feedback collection, and the full board that there is will look like this. So I will copy paste the links to the chat. You can find them there. There is a link for the full board, and you can also use the direct links to each of these tool parts. And something about the Miro. So no registration is needed. You can just click the link and skip the intros. Maybe it will offer you to register first, but that is not necessary. And it will also offer some introduction, but you can skip that. You can move around in the board by dragging the full board around. So just hold the right mouse button and that will work that way. And you can use mouse scroll to zoom in and out in the board. And also if you don't have the scroll, for example, or if you otherwise like, there is this light blue small flag or map in the bottom right of the screen, the same one which is here in the slide. So you can use that to zoom in and out also, and there you can see where you are going in the screen. There are some tools available in the toolbar in the left-hand side, which is also here on the left in this slide. And arrow in the top of that will move the objects in the board, and if you click that, it will turn into a hand, and you can use that to move the board. But you don't necessarily need to find anything from this toolbar, because these icons and stickers that we will use are already available in the board. So in the first part, we will ask you to put a star on this axis for the tool. How did you see it? And then after that, we will ask you comments in 3 words. So, for example, which part of the tool you liked and which had no value to you or to industry that you represent. But let's look at that after 5 minutes. So now it's good to exercise a bit or grab a cup of coffee and